Hello friends, today I'm going to solve LeetCode problem number 787, cheapest flights within K stops. So in this problem we are given an array flights where flight at index I represents the value which is also an array which has three elements. The first one is the value from where we are traveling, the second is the destination, and the third is the price that it takes to travel from this city to this city. Now that we know the about the array, there are also three integer values given to us: the source, the destination, and the integer key. And we need to find the cheapest price from source to destination, and that price should be such that we only have to travel k stops in between the source and destination, maximum of k stops. If we could not find any such value, we are going to return a -1 value. Now let's see how we could solve this problem. So this problem could be solved in two ways, DFS and BFS. So let me first explain you the depth first search approach. So in the depth first search, what do we do? Well, basically we start from the root node, and the root node here will be the source node. So we start from our root node and we traverse along its depth. So we start from 0, we go to 1. Now 1 has two children, 2 and 3. Let's move towards 2 since 2 is of less in value, right, than 3. So we go towards 2. Now what's the value of 1 here? Value of k is equals to 1, right? So we move from 0 to 1. The value of k becomes equals to 0 now, because we have already okay, let's say that way, is it this way. The value of k, from 0 to 1 we moved, right? And from 1 to 2 we moved, and now we know that we have already traversed one stop, and the value of k is also equals to 1, and our destination is not equals to the destination that we want, right? We have only reached 3, we have 2, we have not reached 3. We need to reach 3 by only one stop, right? Only one hop. So what we do is we backtrack, and then we go to the next child of 1, which is now equals to a destination that we want to go. And here in this case, we found our destination within k equals to 1 stop, right? So this will be our answer. Now that is the overall idea behind this, but let me just tell you one thing here. So what if from 0 we have one more node, suppose that's node 4, and from 4 we can reach node 3 as well, and that takes us only 500. The cost is 500 from 4 to 3, and from 0 to 4 it's 100. All right, so now since we have the number of nodes, the number of cities is equals to 5 here. So we start from 0, we go towards 100, and then we go towards 2, same as before, but now we know 2 is not equals to our destination, and we already have one stop. So what we do is we backtrack, so we go back to 1, we go to the next node, which is equals to 3. Now if you just look at this case, we have found our destination within the value of k equals to 1, right, by which has only one stop. So we found our destination. What's the cost here? It's 100 plus 600, which is equals to 700. But is this the minimum price to reach our destination? Well, if you just look at this node 0 to 4 and 4 to 3, it's 100 plus 500, so that would be 600, right? So we have not yet actually reached so this is not our answer. Our answer would be 0 to 4 to 3, which is 600. So now how do we do that? Let's look at it in another way. So we are going to use DFS, but we are going to use it from bottom-up approach. So far I was showing you top-down approach, that is we start from our node and then we traverse until we find our destination. But now we are going to start from our destination, that is the bottommost node, and then we move upwards. So now let's look at this problem here. So what we do is we start from our destination, and the price to reach destination from the destination itself is equals to 0, right? So what we do is we return 0 to all of the nodes that is from where we could reach this node. So we return a 0 here, and the price to reach 3 from 1 is equals to the price 600 plus 0, so that would be 600 itself. Similarly for this node 2, it would be 200, because 200 plus 0 is 200, and for this node 4 it would be 0 plus 500, which is equals to 500. Now so far we have these values, right? Now what we do is from each of these nodes, now we do the same thing. So we start from node 1 and then we go back. Okay, we start from, let's look at node 2 here. So we start from node 2 and the value here is equals to 200, right? That is the least price to reach 3 from node 2. Now what's the price to reach node 3 from node 1? What's the least price? Where the least price would be equals to 100. If we return a 200 here, then the price is 600. Price would be 300, right? Via node 2. But in this case the value of k would be equals to 0. So we do not consider this thing here, and our values is still equals to 600, because we do not want any extra nodes in between. And so what we do is now we return the value 600 here. So now the minimum price to reach node 3 from 0 is what? 600 plus 100, right? Because we returned the value 600, so that would be 700. So now so far we have found the value equals to 700 from via node 1, right? Next let's look at this node. So to reach 3 from 4 it cost 500, right? Now to reach we backtrack, and to reach 3 via 4 is equals to 500 plus 100, which is equals to 600. And now we have two values, right? One is 600, one is 700, and we pick the minimum, so we pick this value. Now 0 has two children, right? 1 and 4. Let's just move to child 1 first. So when we move to this child, what's the total cost to reach node 1 from 0? It's 100, right? It's 100. So the cost is equals to 100 here. Then what do we do is we next move to its next child, which is equals to 4, and the cost is still 100. So we have found the cost of all of its children. Now we do the same thing for its children. So from 1, what we do is we move to its child. So its next child is 2, so the cost to reach 2 from this node is equals to 100 plus 100, which is equals to 200 here. And the cost to reach its another child 3 is equals to 100 plus 600, which is equals to 700, right? So far we have found its cost. Now what about this? From node 4, the cost to reach this node is equals to 100 plus the price, that is 400, which is equals to 600, right? So we got these two price, and so far we are satisfying the value for k, that is the number of stops should be equals to 1, and so far that is being satisfied. Now between these two values, which is the minimum value? Since we had the value 700 and our current value 600 is less than 700, right? It's less than 700. So what do? Is we reject the previous value and we keep the current value. Now from node 2, we move towards this node again here, and then what we find here is the number of stops equals to 2, so we do not actually choose this path. Now let's just suppose we have one more node here, just to give you an example of the number of like base cases that we need to consider. And suppose this has a value of 200 and a 700. All right, so in this case we will first, what do? Is we know that the price to reach 5 is 200. Now from 5 to reach the destination, which is node 3, is equal to 200 plus 700, right? But we know that this value 200 plus 700, we already have a price that is less than this price 200 plus 700, so we are not going to choose this path, right? We are not going to even choose this path, because we need the path with the minimum price, and we already have found the path with the minimum price, which is equals to 600. So we are not going to compute this at all. That is when we have found our solution, the result. So things that we need to consider is the value of k should be greater than -1. If it is -1, then we are going to return back. And also we need the minimum value at that node, right? We need to find the minimum price to reach a given node. So we are going to keep track of the previous values that we have found. So we are going to use a memory to keep that value, so that we can compare. And then also again, if we already have reached that node with the least price, that we are not going to compute it again, right? So we are also going to use that condition. So now let's start coding using our DFS search. So what do we need? Before performing any execution, we actually need to create the graph, that is to create an adjacency matrix. So let adjacency matrix equals to new array. It should be of length, and that is the number of cities, and then for each of the city it will have the number of flights running from that city to another city, right? So okay, let's just do it this way. It's actually the flights. So the flight, what's the value of flight? It has from, to, and the price, right? So from to price, from, so we are okay, push the value to and the price to reach that value. All right, now that we have our adjacency matrix, let's create our memory to store the values that we have already reached. And let's fill it with an infinity value. Now let's create our BFS function. For our BFS function, what do we need? We need a queue, right? So initially our queue, we will push the value source, start from our source, and then from, let's while so this is to keep track of, that is, we are only traversing over the children ones. Now we are going to traverse over each of its child. Okay, traversing over each of its neighbor with and the price of from the adjacency list, and then we check if the distance from neighbor that we have found is already less than the price to reach that node from this source node, that is price plus, okay, price plus the cost of this node, then we are not going to compute because we already have found the least value to reach that distance, to reach that city, right? So we are going to continue, else what we do is we push to our queue. Okay, this is shift value, so we push our neighbor and the cost of that, total cost to reach that neighbor. Also, we are going to set the value of our neighbor as the new price because that is the list price that we have found. So why don't we use this value here rather than computing it again? And finally we return the value to reach our destination.